A century-old Russian math feud between Nekrasov and Markov led to the development of Markov chains, a probability theory for dependent events that has revolutionized fields from nuclear physics to search engine algorithms. How can you predict the next word in a sentence? And how does Google know which page you're actually searching for? Well, the reason we know the answer to all of these questions is because of a strange math feud in Russia that took place over 100 years ago. In 1905, socialist groups all across Russia rose up against the Tsar, the ruler of the empire. They demanded a complete political reform, or failing that he stepped down from power entirely. This divided the nation into two. So on one side you've got the Tsarists, right? They wanted to defend the status quo and keep the Tsar in power, but then, on the other side you have the socialists who wanted this complete political reform, and this division was so bad that it crept into every part of society to the point where even mathematicians started picking sides. On the side of the Tsar was Pavel Nekrasov, unofficially called the Tsar of Probability. Nekrasov was a deeply religious and powerful man, and he used his status to argue that math could be used to explain free will and the will of God. His intellectual nemesis on the socialist side was Andrei Markov, also known as Andrei the Furious. Markov was an atheist, and he had no patience for people who were being unrigorous, something he considered Nekrasov to be. Because in his eyes, math had nothing to do with free will or religion. So he publicly criticized Nekrasov's work, listing it among the abuses of mathematics. Their feud centered on the main idea people had used to do probability for the last 200 years. And we can illustrate this with a simple coin flip. When I flip the coin 10 times, I get 6 times heads and 4 times tails, which is obviously not the 50/50ths you'd expect. But if I keep flipping the coin, then at first the ratio jumps all over the place. But after a large number of flips, we see that it slowly settles down and approaches 50/50ths. And in this case, after 100 flips, we end up on 51 heads and 49 tails, which is almost exactly what you would expect. This behavior, that the average outcome gets closer and closer to the expected value as you run more and more independent trials, is known as the law of large numbers. It was first proven by Jacob Bernoulli in 1713, and it was a key concept at the heart of probability theory right up until Markov and Nekrasov. But Bernoulli only proved that it worked for independent events, like a fair coin flip, or when you ask people to guess how much they think an item is worth, where one event doesn't influence the others. But now imagine that, instead of asking each person to submit their guess individually, you ask people to shout out their answer in public. Well, in this case, the first person might think it's an extraordinarily valuable item and say it's worth around $2,000. But now all the other people in the room are influenced by this value, and so their guesses have become dependent. And now the